Hello all. In this video, we are going to check out the copy constructor. I hope that you have seen earlier videos of default argument, the effect of new keyword in C++ part 1 and part 2. If you haven't, please go and check those videos before completing this task. So we are going to create one public section in this class, and there will be an ID variable which will be of type pointer. Then we will be using a constructor of the class to allocate a memory to this ID variable, new int, and then we will be initializing this ID variable to a value. Let's use a default argument for this, integer val is equal to 0. Now if you create an object, let's create object of this class. The default value for this ID will be 0. So let's print the value. The value of object dot id is equal to, and as it's a pointer variable, I should use asterisk symbol. Now if we compile and run this program, here you can see that the default value of the id variable is assigned to 0. Now let's create another object, a object 1. Instead of creating it independently, I'll be assigning object to object 1. Now let's print the value of object1 dot id. So the value of object1 dot id, object1 dot id. As we are assigning the object to object1, they both are going to have a same value, which is 0 0. Now let's modify object1 dot id to 1, and then we will print this both values again. So let's compile and run. I should use the asterisk symbol. Let's compile and run. So here you can see that initially, before modifying this object1, the value of the object.id was 0. Then object1.id was also 0 because we assigned object to object1. After modification of object1.id, the object.id has also changed to 1. So we have seen this in detail in the default argument, effect of new keyword in part 1 and part 2. So let's use a copy constructor to overcome this limitation. The copy constructor accepts an argument of type constant and class name, and it is going to use a reference. Let's use O as a symbol. Now in here, what we will do is we will simply say the id is equal to new integer, then star id is equal to star o dot id, and this shall solve the problem. Let's compile and run again. Now look at here. The object.id originally was 0. When we copied the object into object1, then object1.id was also 0. Then we have modified object1.id to 1. In the earlier case, it was also changing object.id value. Now, as we are putting a copy constructor, it has overcome the limitation of a default constructor, and object.id has not changed. So even if we have modified object1.id, it has not modified object.id. So that is how we can overcome the limitation of this default constructor by using copy constructor. So in theory, what happens is, by default, constructor performs bit by bit copy of values. So when it copied, when a default constructor was used, it copied all the values from the right side object to the left side object. So it means that it copied the value of id variable as it is to the object one's id variable. And we know that id variable is a pointer variable, so it keep the address. So that bit by bit copy did not work. To overcome this problem, we are using a copy constructor in which id variable is assigned a fresh memory. Then the star.id is assigned with the value of o.id. So this o.id represents the right side object, and this id represents the current or the calling object, which is object 1. And this is how the copy constructor can overcome the limitation of the regular constructor in the case of new keyword. I hope you got the concept. Thank you.